Hello everybody. Today we're going to discuss the second question from section 2 of Challenging Problems in Geometry by Alfred Posamentier and Salkind. What we are doing is an isosceles triangle PQR with PQ equal to PR. This side is equal to this side, and we need to show that KS, KS this length is equal to QM this length plus ST this length. This length is equal to this length plus this length. And the book has asked us to solve this problem using two different methods. And the book itself has described two different methods. So we need to come up with two methods which are different than given in the book. Okay? Now I'm going to describe three solutions. First one will be the second solution of the book. The second solution is my first solution, and the final solution is my second solution. Okay? All right. Let's get started. By the way, PQT and SQR PQT and SQR, they're collinear. Okay, PQ and T are collinear, SQ and R are collinear. Means this is a straight line, this is a straight line. All right. Let's see. Let's suppose that this angle is alpha. This is the first method, by the way. First method. This is the first method. If this angle is alpha, this angle will be 90 degrees minus alpha, because this is a right angle triangle. So vertically opposite angles. So this angle is also 90 degrees minus alpha. But we have PQ is equal to PR, and so since this is 90 degrees minus alpha, this angle is also 90 degrees minus alpha. Okay, this angle is also 90 degrees minus alpha. And from right angle triangle SRK, from right angle triangle SRK, since this is 90 degrees minus alpha, this angle will be alpha. Okay, now let's make a construction. Let's drop a perpendicular from Q on KS as shown, and let's call this point Q dash. So we've basically drawn QQ dash perpendicular to KS. Now let's see what happens. Now in triangle SQT and SQQ dash. Let's see what is here. SQT and SQQ dash. A side is common and two angles are equal. This angle is equal to this angle. This angle is equal to this angle. So in these two triangles, a side and two angles are equal. A side SQ and SQ, and two angles alpha 90. They are equal, two pairs rather, right? So these two triangles are congruent, as a result of which we get ST is equal to, since triangle SQT is congruent to triangle SQQ dash, we get ST is equal to SQ dash. All right. Okay. Now let's call this equation 1. Now since Q dash KM is a rectangle is a rectangle, okay, is a rectangle, we get, what do we get? QM is equal to Q dash K. QM is equal to Q dash K. Okay? Now, using whole part axiom, we get Ks. We need Ks, right? Ks is equal to KQ dash plus Q dash S. Okay? KQ dash or Q dash K plus Q dash S or SQ dash. Q dash. Alright. Q dash K is equal to QM. Q dash K is equal to QM from 2, and SQ dash is equal to ST. Completing the proof. Okay? We get this from 2 and we get this from 1. Okay? So, this is the first method. Now the second method, and for me it was the easiest method. Okay? I hope this is clear. For the second method, let's get rid of this. We don't need more space. Take this one. Okay. For second method, we don't need any of these. Okay? We don't need any of these. We don't need alpha. We don't need 90 degrees minus alpha. Nothing. So for second method, what we do is we join PS. Okay? We join PS. We join PS. Join PS. Now let us see, using whole part axiom, what we are going to get. PSR, triangle PSR. PSR is equal to, in area, okay, in area, triangle PSR is equal to triangle PSQ. PSQ plus triangle PQR. PQR. Now let's say PQ is equal to Q, PR is equal to X. Okay? Equal to X. Then, let's see. This is PS. What we have done so far is this is PS. Something like this. Something like this. Something like this. Okay? P, S, Q, R. This triangle is equal to this triangle plus this triangle. That's what we've done so far. And yeah, this is X, this is X. Okay? Now let's see. PSR. Okay, PSR. PSR. Let's focus on this triangle. PSR. We have this. Isn't it? We have this. K. Okay. So, the area of this triangle is half times X times KS. Isn't it? half base times height. So let's say this is 1 by 2 times x times ks equals to, we need triangle PSQ. Okay, triangle PSQ. This is P, this is Q, this is Q, this is P, this is S. And PQ is equal to X. So this is X, right? Considering this triangle. And we further have something like this. This is T. So again, area of this triangle is half times the base is x, okay, base is x, and the height is st plus. Now finally let's look at triangle PQR. Let's look at triangle PQR. P, Q, and R. Okay, we have QM like this. This is equal to x. This is equal to x, right? So the area of this triangle is half base times height, means half x times QM. Now we can cancel out half x, half x, half x on both the sides, which will give us Ks is equal to Qm plus St. Okay, this is it. This is the second method. This was the second method. This was the second method, and I find this method to be the easiest. Now for the third method. Now before beginning with the third method, let me tell you this. I will never suggest you to solve this problem using the third method. Okay, I came up with the third method because I was supposed to give two solutions which were different than the two solutions given in the book. My two solutions should have been different from the two solutions given in the book. That's why I came up with the third method. Otherwise, I won't suggest you to use the third method because it's kind of insane. Okay, it's kind of insane. Okay, for the third method, I'm going to use a system of coordinates. All right, going to use a system of coordinates. Now let's see. First, let us take QR to be 2A and QS to be C. QS to be C. Okay. Now what we do is we drop a perpendicular like this. O. Okay. PO perpendicular to OR, and we also let OP is equal to B. Now we take O as the origin. Okay, we take O as the origin, OX along OR, positive x-axis here, positive y-axis here. All right. Okay, positive x-axis along OR and positive y-axis along OP, like this. So this is an isosceles triangle. Okay, this is an isosceles triangle. This is perpendicular, so it must bisect the base. Must bisect the base. as a result of which this length will be A, and this length will be A, and so the coordinates of R, okay, let me write, yeah, the coordinates of R are A comma 0, and the coordinates of Q are minus A comma 0. This is A towards the negative direction. Okay, we've supposed this length to be C, and so the coordinates of S are minus A minus C comma 0, because this length is A plus C and is towards the negative direction of the x-axis. Okay, now the coordinates of P, this length we've supposed it to be B, isn't it? We've supposed this to be B, all right, this length to be B. So the coordinates of P are 0 comma B, 0 comma B, and this is the third method. Okay, now we need to find this length, we need to find this length, and we need to find this length, show that this plus this is equal to this. Okay, for that we need the equation of this line and the equation of this line. Since this line passes through A comma 0 and 0 comma B, equation of PR, the equation of PR is x by A plus y by B is equal to 1. X by A plus y by B is equal to 1, which is nothing but bx plus ay minus ab is equal to 0. Okay, the equation of PR is this. Let's find the equation of PQ. The equation of PQ, we see that passes through minus A comma 0 and 0 comma B. So the equation of PQ is x by minus A plus y over minus B, y over B is equal to 1. This is bx minus ay plus ab is equal to 0. Okay, all right, now qm, okay, qm, length of qm, length of qm is the distance between q and PR, the distance between q and PR, which will be given by we need PR, yes, b times x coordinate of q PR. So we need the equation of PR. Okay, and q means we need coordinates of q. B times the x coordinate of q, a times plus a times the y coordinate of q minus ab over square root of b square plus a square, like this. Okay, and since a, b, c, their lengths, they're positive, and so this simplifies to be, this is 0 minus twice AB means twice AB over square root of A square plus B square. Okay, all right. So we have QM is equal to twice AB over the square root of A square plus B square. Now we need ST. We need ST, which is the distance between the point S. This is the point S, isn't it? Yes. The point S and the line PQ. Distance between S and PQ. So PQ means we need the equation of PQ, and S means we need the coordinates of S. So the numerator we're going to get B times the x coordinate of this thing right here, minus A minus C, plus minus A times the y coordinate of S. So A times the y coordinate of S plus AB. AB over B square plus minus A whole square. So B square plus minus A whole square. AB minus AB, these two get cancelled out. So these get cancelled out. This is already 0. Minus BC and B and C are positive, so we can remove the minus sign and we'll simply get BC over square root of A square plus B square. Okay? So next we need PR. So I'll erase PQ. Okay? I'll get rid of PQ. So what we have so far is QM is equal to twice AB over square root of A square plus B square. ST is equal to BC times BC over square root of A square plus B square. Now we're going to need KS. We're going to need KS. So KS is equal to the distance between the point S and the line PR. Okay. PR. Woof. It's getting kind of insane if you ask me. Okay, we need the equation of PR and the coordinates of the point S. So B times x coordinate of S means B times minus A minus C plus A times 0. A times 0 and minus AB. Minus AB over the square root of B square plus A square. Okay, B square plus A square, which is equal to everything is in minus. So this is minus twice AB, minus twice AB, minus BC over the square root of A squared plus B squared. And since this is positive, the quantity inside it's negative, and hence the absolute value will be BC plus twice AB over A squared plus B squared, like this. Okay? Alright. So Ks is equal to BC plus twice AB square root of A squared plus B squared. Now, let's continue. We can write it as BC over square root of A squared plus B squared. It's getting darker. So, yeah. Ks is equal to BC plus twice AB. Okay? So BC by square root of A squared plus B squared plus twice AB over square root of A squared plus B squared. Now, since this is ST and this is QM, we shall conclude that Ks is equal to QM plus ST. Okay, plus ST. All right. 3 different methods for the same proof. All right. And once again, I don't suggest this method at all. This is too much of work for a very small thing. Okay, too much of work for a very small thing, and I did it this way just because I needed a second solution which was different than the one given in book, the ones given in the book, the 2 solutions given in the book. That's why I came up with the third method. Otherwise, I'll never suggest you to do this question using the third method. And by the way, okay, these may not be equal. All right, that's all for today. Take care. Thank you very much.